Okay, it turns out the problem was two things. It was this microcontroller being in its socket. As the stepper motor is turned, I think it caused one of the pins to hop on one of the connections and causing it to reset, causing everything to freeze. Also, I think, what was the other thing? Well, I don't remember. Anyway, let's try it again to go up. Oh, also I think the oscilloscope on those connection lines was causing a problem. I don't know what that would have been, but we'll try it. So now we're loading into the vehicle. So that motor on top and the side motors are working in different frequencies and different step signals. So as the side ones get closer, they start to slow down to touch off. So they slowed their frequency down. You can see it on those green lights there. And then they're going to touch off one at a time, and you'll see those green lights on the two bottom boards stop when they touch those limit switches. So the top one did, speed motor, the right side, and then the left-hand one. So those have stopped completely, and the top one's still going because it's slow. It takes a while to get up there, but again, this is proving concept. I just want to show that motion is possible. To improve speed, you would add more voltage. You can't really run these motors off a car battery, unfortunately. It's just not enough voltage to get the speed you would want. We might, yeah, and because of the low voltage, you're not dealing with this constant of torque, really. It's pretty shallow gradient to get up to the max current. So now it's going to touch off, and it'll stop as soon as it touches the limit switch. It's allowed. The reason I had to do the touching off was because these stepper motors might miss a step or so, and that would cause misalignments over time. So each cycle, the mechanism touches off to home itself in the entrance and exit. That allows us, or in the loaded and unloaded position, this allows synchronized motion between both sides, and it allows calibration of the mechanism in both the loaded and unloaded position. So now we're going to try and unload it, and if all goes well, it should unload. Looks like it's going to. How about that? Unfortunately, it's pretty loud, and that is partially due to the non-micro-stepping of the motors. So those motors are kind of snapping into place rather than gliding through their revolution. That's a big portion of it. Oh, let's see. And those side motors should stop. Top one, bottom one, and now we're waiting on the middle one. So each time those motors stop, that's basically that whole serial communication transaction goes on. So the transaction goes on, and then it does something with it almost instantaneously. So those buttons, I mean, they're under very little pressure. Nothing terrible at all. So much, actually, I think we need to have them under more pressure, because I think we need to turn it like a couple more steps just to put some pressure on it, because they were hopping. The buttons were hopping. Like if it just barely gets on there, it'll turn it off, but jiggle around on the road for a while, and it would come back off. So we're getting close here, and we're touched. All right, let's do a loading cycle just to make sure that everything is working, and it is. Holy cow. Working how you would intend it to work, which for most of my projects that isn't how it goes. It's really slow, but hey, it is what it is. So this is something I'm gonna our professor wants this, so I'm gonna go take it to him today. It's been taking up room in here, and I gotta move my CNC that I'm building into here. Just right now it's out in the living room. Just taking up room. So one project out of the way, and it'll let me sleep at night. So we'll let it load itself, and that'll be it. So I'm not even holding anything, and it's going through its cycle. So this would allow, I mean, you could automate the rear trunk hatch on your vehicle, so you could just like push a button, it would load it for you and close the rear hatch, and you could get into the vehicle. And another thing to note is this mechanism isn't for people who are completely immobilized. It was designed for people who need a wheelchair that can get around over short distances. So they could walk from the back of their vehicle to the front of their vehicle, but would like a wheelchair to go long distances. So it is not a complete, it's meant not for motorized wheelchairs. It's only for manual wheelchairs. So there we are. Touching off. And we made it. Turning off the H bridges and the fan. Alright, so the program worked. That's, I guess, all I have to say. Alright, have a good one.